All right, good morning, everybody. So we're in the files notebook. So this is the file. This is the notebook that tells you how to move, remove, and rename and copy files. It also talks a little bit about creating files, but there's really only one command that we're going to use to create a file today. All right, so let's scroll down to here, file names. So I talked briefly about file names earlier in the course, right? So a file name is a name associated with a file. In Unix, you're allowed to use any character in the file name except for the /, right? So remember, / is either the name of the root directory or it's the directory separator in a path, right? So because it's a directory separator, Unix does not allow you to use that as a character in a file name. Right. Now remember, if you're from Windows, the directory separator is the / instead of the /. And so that's confusing. So make sure that you're always using the / in Unix. You're also not allowed to use this funny character. So /, remember, is the escape character. The 0 here turns out to be important. So /0 is called the null character, or the character corresponding to nothing. It is in fact a character, so it's not empty. Right? It has the numeric value of 0, which is different than the character 0. All of that is not that important right now. But you're going to see /0 a lot when we talk about C, because C uses it for a special character as well. In Unix, file names, this is true of Mac as well, because Mac is a Unix-like environment. File names are case sensitive. Right? So little abc is different than the file name big ABC. In Windows, this isn't true. Windows doesn't care about case in your file names, which is super annoying when you're moving files back and forth between Windows and Unix. A file might appear to have be in all lowercase in Windows, but then when you move it over to Unix, it turns out everything's in uppercase. And that's because Windows, the File Explorer doesn't actually show you the case properly in many cases. Right? So Windows, case is not important in the file name. Anything with a dot, any file name that starts with a dot is considered to be a hidden file. Right? Now hidden doesn't actually mean hidden, right? So you can look at it, you just have to ask ls to see the file. So remember, you use a little a or big A to list those kinds of files. If you're using a graphical file explorer type tool in Unix, you have to configure the tool to show you whether or not to indicate whether or not you want to see the hidden files. All right, so there's a bunch of, remember, there are a bunch of symbols that are considered important to the shell, right? And so it's generally suggested that you don't use these symbols in your file names, right, to make your life easy. Basically, the rule of thumb is use English letters and the numbers 0 through 9, or the digits 0 through 9, sorry, and you won't have any issues. Right? But you will come across file names that have unusual characters in them, and you need to know how to deal with them. Right? So remember, how do you deal with them? You either have to escape the character with a / or you need to use quotes. If you want to space, use the underscore instead, right? Because the space is also important in Unix. It's the word separator in Unix. Right? Again, Windows doesn't care about the space so much. Mac provides the illusion that it doesn't care about the space, but in fact does care about the space. Right? Never use the hyphen as the first character of a file name. Right? Why? Because the hyphen is also the switch for an option in a command. So if the hyphen is the first character in a file name, most commands will interpret it as an option instead of the file name. So don't use the hyphen as the first character. You can use it elsewhere in the name safely, but not as the first character. Everything that I just told you about results in this. Right? So if you search online for anything Bash or Unix related, a lot of the information that you will find is why you have to do things in a certain way to deal with unusual characters like this in a file name. Right? So if you avoid those, you'll generally be safe. Now the problem is that you can't always avoid them because you're not getting files. You're not always producing your own files. You might be getting them from somewhere else. So you need to know how to deal with those characters as well. All right, so creating files. So you only know one way to create a file so far from the command line. Right? The only way you know how to do it is via a redirection. Right? So run some command, redirect the output to a file, and that makes a file. So that's definitely one way that you can make a file. Obviously, the other way that you can make a file you run some program like, I don't know, Visual Studio Code or Eclipse or something like that, right? You save a file using your program and it produces a file for you, right? If you want to make them from the command line though, typically what you have to do is you have to call a command that creates a file for you, like touch. So if you want to create an empty file, a new empty file, touch is one of the commands that you can use. Touch actually changes the modification time of a file. That's its intent. But if you try to touch a non-existing file, touch will create the file for you. So if I list the contents of the directory I'm currently in, we see there's a file called a.txt. Right? There's a file called file1, and there's something, words starting with an A and an arrow. This is a soft link, if you're wondering what that is. The end of this notebook explains what this is. So those are the 4 files that are in this directory. Right? If you run the touch command, file1, file2, right? And I list the contents of the directory again. So I'm just going to jump out to the shell directly to do this so that you can see them. Right, so I was in this directory. If I do ls now, you can see file1 and file2 have now appeared. Right? There's also a file3. What did I just do? Sorry. Oh yeah, file1 was already here. So I'm going to touch file2 and file3. So file2 and file3 now appear. Right? How big are they? Looks like they're 0 bytes big, or 0 blocks big. So they're empty files. There's nothing in them. And if you try to list output their contents, right, you can see there's nothing there. Okay, so if the file already exists, then what touch does is it updates the access and modification time of the file. Right? So file2 and file3 were created today at September 16th. My system time is wrong on my shell. So that's actually, that's what time my computer thinks it is right now. Well, that's what time Unix thinks my time it is right now. Windows thinks it's 8:37. It looks like my Unix is running a little bit behind. Okay, so if I touch file1, oh wait, what's file1? File1 was, okay, September 2nd, that's good. So that was a while ago, right? If you touch file1, right, so notice file1 is an existing file, right? And now its access and modification time change. Right, so now touch has adjusted the update, the modification time for file1 to indicate that someone has now looked at file1 at this particular time. Right, so there's touch. So it's the easy way to make an empty file. Right, if the file already exists, it simply updates the modification time for the file. Okay, so if you want to make that makes a file, but it won't make a directory. So if you want to make a directory, the command that you want is make dir, so mkdir. And so make dir will create one or more named directories. Right, so in this directory, there's only dir1, right? No other directories here. So if I run this little script here, this little piece of shell code here, we're going, echo is the command that you can use to print a string. So I'm going to print before make dir, right? Remember what and does, and if the previous command succeeds, then and will, the double ampersand will run the next command. Echo will almost always succeed, right? You're just printing something to the terminal. So this should list the contents of the directory, right? Then we're going to make 2 directories, right? So you can make 1 or more directories by name. Here I'm making 2, so dir2 and dir3. And then I'm going to print make dir and list the contents again. So I should see dir2 and dir3 the second time, right? And there they are, right? So make dir makes a directory. If you try to make an existing directory, make dir will complain. Right, so there's dir2 and dir3. So if I try to make dir2 again, or dir3, it'll complain, right? So there you get an error. So make dir will not remove a directory, for example. All right, now often you're not going to make just one directory. You're going to want to make a directory, and inside that directory, you'd like to make another directory, and so on and so on and so forth. So you would like to make a hierarchy of directories, right? So imagine that might be a year, that might be a month number, and that might be a day. So you might organize your files. There might be a good reason to organize your files by year, month, day, for example. Right? So if you try to do this, it turns out makedir complains. So let's see what happens. Right? So it says it can't create the directory xxyyyzz, no such file or directory. So the error message isn't that useful. Right? Obviously, xxyyyzz doesn't exist. That's why I made it. Right? So what it's complaining about is that makedir is trying to make the directory zz inside the directory yy, inside the directory xx, right? X, right? And so what it's complaining about is that it can't find the directory xxx, right? Or yy, or xxxyyy, right? Because it needs these two directories to actually make zzz. So what it's really complaining about is it can't actually, yes, it can't actually find the directories xxxyyy. Right? So the solution is, well, I have to make xxx and yyyy. Right? So you could do it this way. Right? So make that directory. Once that directory is made, I can make that directory. Once the directory yyyy is made, I can finally make zzz inside yyyy. Right? But that's a pain in the butt. It's too much typing. There's a make p option for makedir. So let's make the parent directories if they don't exist. Right? And so if xxx and yyyy don't exist, makedir will also make those directories. So now this is happy. And the tree command will print out the tree-like, will list the contents of your directory using a tree-like structure. So in assignment 1, there was a picture that looked something like this. And that's how I made that picture. I don't believe tree is installed by default on most modern Linux installations. So you'll have to install that on your own if you want to use it, probably. Right? I think it's also, I don't know if it's true on Mac or not. I don't use Mac enough to know for sure. All right, but here you can see xxx, and then there's yyyy, and there's the directories. Right? So makedir directory name will make the directory. Right? It can be a relative path. Right? You can use an absolute path. Right? So for example, so what directory are we in? So we're here, so I can, from this directory, I can make a directory in my home directory. Home Burton, some new directory. That, and if I list the contents of my home directory, remember the tilde expands to the name of my home directory, right? So you can see some new directory has been created there. Right? Similarly, you can use a relative path, right? So that was the, so here's the directory xxx. So if I wanted to, I could make a directory in xxx called some new directory. Right? So I can use a relative path as well. That works just fine. Right? There's some new directory now. Right? Absolute path, relative path, it's fine. They all work with makedir. In fact, they work with most commands that take in a file as an argument. All right, redirecting command output. So we saw this briefly, or not briefly, we saw this in detail in the previous lecture. So I'm not going to go over this again. Remember, if you want to redirect to a file, you can use the greater than symbol, right? That's the redirection operator. So that will redirect standard output. That just sends the output of a command to a file instead, right? If you want to append, right? Don't forget it's the double, right? So single, overwrite the file mu.txt if it exists, right? Double, add to the end of the file mu.txt if it exists, right? If it doesn't exist, create the file and then output the contents to the file. So we'll skip over that. Okay, so you've got a file now, or you know how to make a file, you know how to make a directory. What about moving a file? So moving is called, so the move command is mv, but what mv actually does, it does two things. It can rename a file, or it can move a file, right? So if you want to change the name of a file, you specify the name of the file that you want to change, right? And then you give it the new name of the file. So here I'm going to make the file called a file, right, using touch. Then I'm going to rename a file to b file, right? So if I run that, there's b file, right? If you'd run ls after touching the file, you would have seen the file a file instead, right? So rename this file to that file there. So when I say file here, I mean a regular file, right? Okay, so the destination directory, the destination file name can be in a different directory, right? It doesn't have to be in the same directory. So I've got a B file. So if I'd like to take B file and now move it into dir1 and rename it C file, right? I can do that as well. So this takes B file, right? And renames it to C file in the directory dir1, right? So if I do that and I run ls, right? So you look there, there is no B file anymore, right? Because I moved it to dir1, right? If I list the contents of dir1, I now see that there is a C file, right? Now, do I tell it? Oh, right, okay. So that will rename, so if you specify file name and file name, that does a rename of the file, okay? Now, if you specify file name and then a directory name, that actually moves the file without renaming it, right? So move a file having that name into the directory that has that name. Okay, so let's make Z file. So I'm going to use, let's do this in the terminal. Okay, so I'm going to touch Z file. Oh, sorry. Z file, right? There we go. So there's Z file, right? I'd like to move Z file into this directory, and I don't want to change its name, right? So move Z file into dir1. Right, so notice Z file is gone, right? It's no longer in the directory that I'm currently in, right? And if I list the contents of dir1, there is Z file now, right? So that that will actually move a file. You can rename and move at the same time, right? So the previous command up here, where to go? Here, right? So that is that will move to the directory dir1 and rename the file, right? That simply moves the file to directory 1 and does not change the name of the file, right? Again, these can both be full path names, right? So you can specify a relative path or an absolute path to a file. You can specify a absolute path or a relative path to a directory, and it will move that file, whatever file that was, into that directory. Right? So you don't have to be in the same directory as a file to actually move it or rename it. Okay, so if you rename or move a file, an existing file, right, and the destination file already exists, then you will overwrite the destination file. Right? So here, so X file and Y file. Okay. Okay, so I'm going to make two files, X file and Y file. Right? I'm going to edit the contents so that we can see what they are. So I'm just going to put an X in X file, and I'm going to put a Y in Y file. Like that. Right, so cat X file, there's an X, right? Cat Y file, there's a Y. Right, so if I move X file, change it, if I rename X file to Y file, so move X file, Y file, right? Enter. Right, X file should be gone, and it is. Y file is here, which is good, because that's what I told move to rename X file to. And if you look at the contents of Y file, right, it now says X, right? So it's the contents of X that are now appear when I use the name Y file, right? So move will overwrite the destination file, and it won't warn you that this is happening, right? So it blows over the contents of Y file, and whatever was in Y file is no longer accessible anymore. In Unix, this is irreversible. So there is no way to get back, there's no guaranteed way to get back the contents of Y file anymore, right? It is effectively gone. So if you are worried that you might be overwriting an existing file, you can use the -I option with move. -I is interactive. right? So let me redo that sequence of commands. So I'm gonna put y file back to y, and I'm just gonna do it this way. Okay, there's x file, there's y file, right? So if I use -i like that, right? It will now say, hey, are you sure you want to overwrite y file? You can now press y or n for yes or no. If you say no, right, it does not move x file or does not rename x file to y file. Right? If you say yes, it will overwrite y file with the contents of x file. All right, you can also move bunches of files at the same time. Right? So file 1, file 2, file 3. Right? I would like to move, well, file 1, file 2, file 3, there's an x file, there's a y file. Right? I would like to move all of those into dir3. Can you do that? The answer is yes. It's move star file star. Right? Move every file name that contains the word file, right, into dir3. All the files are gone. Right? They're now in dir3. Right? So this form of move will let you specify one or more files, right, and a destination directory. Right? So you can move a bunch of files to a new directory. What you cannot do is there's no way to move a bunch of files and change all of their file names in a particular way. Right? So suppose I had file 1, file 2, file 3, right, and I wanted to change the F to a G, or for some strange reason, or sorry, I wanted to put the word my in front. So my file 1, my file 2, and my file 3. There is no way to do that using MV. Right? If you try to do that, it won't work. So move file star, so everything that starts with file, to my file star, right? You think that would be nice, right? Can't do it, right? So it thinks that's a directory. It won't actually let you do that. Right, so there's no way to group rename a bunch of files. There is no way to move a bunch of files to a bunch of directories. Right? In order to do those sorts of things, you have to either use some other command that's capable of doing it. I'm not sure if there is one, or you have to write a little bit of code to do it yourself. Okay, what about removing files? So you've got a file now, you know how to move them around or rename them. To remove them, the command is rm, right? It's short for remove. Now, what you need to remember is that in Unix, right, file deletion is effectively permanent, right? There is no reliable way to completely recover the contents of an undeleted file. Right, so what happens when you remove a file is that the data that's associated with the file, right? So remember, the inode tells Unix where the contents of the file are actually located on disk, right? The inode itself is not, the data on disk is not necessarily overwritten when you remove the file, right? So in principle, if you know where the contents of the file are on your disk, you can go back and recover the contents, right? The problem is that the way Unix works is that even if there's only one user on the computer, the operating system's doing stuff as well. So as the operating is doing stuff as well, it might choose to overwrite the part of your disk that contains the information belonging to your file because it's doing some other work and it needs some disk space for something. So there's no guaranteed way to recover the contents of the deleted file. Right? There are tools that you can purchase or download that will attempt to recover the contents of a file, but none of this stuff is guaranteed to work. Right? It's considered to be one of the flaws of the original design of Unix. Right? It's not surprising. So remember back when Unix was developed in the 70s, permanent storage was extraordinarily expensive. Right? So we think of permanent storage, so your disk now is quite cheap. Right? But back in the day, whatever corresponds to a disk turned out to be extremely expensive. And so it kind of made sense that you don't want to, that you'd want to reuse any quote unquote disk space if it was no longer needed. So if you remove a file, it immediately became, the contents of the file on disk immediately became available for being overwritten. It wasn't a disk back when when Unix was created. It was something else, right? But unfortunately, that still is true today, right? So if you want to remove one or more files, rm and then the file name, right? These are regular files only, right? And again, you can use wildcards to specify groups of files, right? So here I'm going to, looks like I'm going to make a bunch of files. Okay, so we got a bunch of files: A text, B text, C text, D text, capital A text, right? I can remove A text and B text by asking rm to remove those files, right? So run that, right? Notice A text and B text are now gone, right? You can remove all of the files ending with .txt using star.txt, right? Or star.txt if you want to remove the files that end with the extension txt, right? So, bloop, right? Notice that all the other files are now gone, right? Also notice that word starting with A is now in red, right? So what this thing here was what's called a soft link. So it was a soft link to the file a.txt, right? And so all a soft link is, it's just another name for a file. Right? That's all a soft link is, right? So if I remove the file that word starting with A was pointing at, right? Then it's called a dangling link now, right? Because it now points at nothing, right? So that's why it's showing you this in red, right? It's trying to indicate to you that this link is no longer valid, right? It doesn't remove the link, right? So this name still exists. It's just this name refers to nothing now. Right. If you want to, again, you can use -I for the interactive prompt, right? And it'll ask you, do you want to remove this file? Yes or no. Do you want to remove this file? Yes or no, and so on and so on and so forth. Right. Okay, rm will not remove a directory unless you tell it otherwise, right? If you want to remove an empty directory, there's a special command for that, right? So rmdir, whoops, sorry, will remove an empty directory, right? So if I make a directory sumdir, there's sumdir, right? So I just made it so there's nothing in it, right? It's empty, so I can remove it using rmdir, right? So it's gone now, right? If you try to remove a directory and there's something in it, there's a file or directories in that directory, rmdir won't do it for you, right? So here I'm going to make a directory sumdir. Right? I'm going to create the file sumfile inside sumdir, and then I'm going to try to remove sumdir. Right? So make dir, rmdir now complains. Right? It says the directory is not empty. Right? So it turns out rmdir, I don't think it will anyway. Let's see what it does. Man, rmdir. Okay, I'm going to check to see if it can actually remove a non. Oh, here. So the answer is no. Right? Remove the directory or directories if they are empty. Right, so if you have multiple empty directories, you can remove the multiple empty directories with one invocation of rmdir. I just wanted to know if there's a way to remove a non-empty directory, and the answer is no. Okay, so what if you do want to remove a non-empty directory? Because there's lots of cases where you've made a directory, it's got a bunch of files in it, you don't care about them anymore, you'd like to get rid of everything. Right, it would be terrible to have to individually remove all the files and then remove the directory. Right, so rm has a flag -r that will recursively remove the contents of a directory, right? Now remember, rm won't ask you by default, right? Do you want to remove this stuff? So it will really remove everything, right? So recursively remove the contents of sumdir. Let me go in and fiddle with sumdir just to show you. So where is it? Okay, so I'm going to go into sumdir. There's one file in it, right? I'm going to make a directory. I'm going to make a bunch of directories. X, Y, Z, and then I'm going to put something in Z. Some file. Oops, drat. Touch, Z, some file. Sorry, touch, X, Y, Z, some file. There we go. All right. So there's X. Inside X, there's Y, and inside Y, there's Z, and finally inside Z, there is some file. right? So I'm going to go up one directory. Sorry, ls. Okay, so I would like to remove that directory and everything that's inside of it, right? So rm minus r sumdir, right? Recursively remove some directory and all of its contents, right? It disappears. It doesn't say, are you sure, right? It doesn't ask you anything. It's gone, right? Sumdir is gone. And all of the files and directories inside of sumdir are also gone, right? And there's no way that I can get them back at this point in time. Okay, so you have to be, so when you're doing your assignments, right, and you're playing around with these commands, right, be very careful about what you're doing, right? They will overwrite existing files. Remove will remove existing files without asking you, right? So it's possible while you're working on assignment 2 or assignment 3 or 4, 5, or 6, and you're practicing your Unix commands, that you remove all of your assignment directories, right? Or you remove all of the files in your current assignment directory. There's no way for you to get them back, right? So be very careful when you're using RM, MV, and CP, right? They will overwrite existing files for you. If you're a system administrator, so if you're someone who has root permissions, right? Whatever you do, do not go into the root. Do not go into the root directory. Right? Remember, the root directory is the start of all the directories on your system, and do rm minus r star. Right? Recursively remove everything in this directory, so that will delete your entire file system if you have the permissions to do so. Right? And really, whatever you do, don't put the F in. Right? The F means force. So if you try to remove a file and you don't have permission, if you try to remove a file and you don't have write permission on that directory, right, RM will normally complain. But if you force it to, you can override the permissions and actually delete the file. Right? So that'll blow up your file system, which will more or less crash your system, and now your entire file system is gone. So don't do that. If you go on the internet and search for removing the root directory, you'll find all kinds of horror stories from system administrators when they've done this to a running production system. That's not good. Someone did that with, I think, Toy Story. So the first version of Toy Story, so the way they rendered that, it was rendered on Unix workstations. Someone nuked the entire directory containing all of the assets, so it was gone. There was no backups either for it. And so the only reason they didn't have to recreate everything from scratch or go bankrupt was because someone had copied everything onto their home computer. And so there was, someone had a slightly older copy of all the files. Okay, so you can Google that too if you're interested in that. So Pixar almost met with disaster because someone did RM something somewhere they shouldn't have. Okay, so CP will copy files. So you can copy a file onto a new file. So make a separate copy of the file with a different name, right? You can make a separate copy of the file in a different directory, right? Or you can copy a bunch of files into one directory, right? But like MV, you can't copy a bunch of files into a bunch of different directories, or copy a bunch of files onto a bunch of different file names, right? All right, so CP works more or less the same as MV, right? If I'd like to make a copy of the file having that name, right, you just write copy source file, destination file, right? If the destination file exists, copy will overwrite the destination file, right? So here I've got, oh wait, this is not gonna work because I deleted all these files. Where am I? 2024 notes, bash. Okay, so I don't have, I guess this, I didn't proofread this notebook carefully enough. Okay, I need to make a text in awords.text. Sorry, a.text. Is that right? Yes. Okay, so I have a file called a.text. Let me put something in it. Aardvark, and So a bunch of words starting with A. Right? If I'd like to make a copy of that file, right, you just say which file you want to copy, right, and what would you like its name to be, right? So I think it's A, what do I call it? A words. Like that, right? And now you've got a copy of a.text. So it's important here what the word copy means, right? If you're taking 124, you know that copy doesn't always mean copy. So it turns out there really is on your disk, right, a copy of the contents of a.text, and there is in a separate place on your disk, right, there exists the contents of a words.txt, right? So there really is a full-blown copy of these two files. Right? So if you look in a.text, that's the contents, and if you look in a words.txt, the contents are there. Right? If I change the contents of a.text, right, the contents of this file do not change. Right? So they really do exist separately on your disk. Right? If you've got a bunch of files that you would like to copy somewhere else, right, into another directory, you can do so. Right? So I can copy all of the files that start with uppercase A and end in txt, and I can make a copy of those and in dir1. Oops, sorry. So copy a star text into dir1. Right? Now, copy doesn't affect the original files, so they're both here. Right? If I look in dir1, though, there's a.text and a words.txt, and if you look at their contents, dir1 a star. Right, so all the files starting with A, right, you can see there's the contents of a.text, there's the contents of a words.txt, right? So there's now 4 copies of the same file on my disk now, right? You can copy directories if you'd like, and their contents using -r. So again, this is recursive, right? So recursively the contents of dir1, right, into a new directory called words, right? You don't have to copy to an existing directory, right? You can copy will make a copy of dir1 and save that copy in the directory words. So cp-r, right? Like that, right? And there's now a directory called words, right? If you look inside words, right, there's an a.text, an a words.txt, a c file, and a z file. So there's now 6 copies of whatever was in a.text. Right. All right, linking to files. I'm going to skip this section here. You can read about it if you're interested in this. I'm not going to ask you about this in this course. If you're using Unix or Linux at all on a regular basis, you probably want to read this because Unix uses linking a lot. But I don't think it's important that you know this in this course. So if you want to take a look at the rest of the contents of the rest of the notebook, I won't ask you about it on any of the tests, and I won't ask you to use it on any of your assignments, but it's here if you need to find out about it. All right, so I think we're now on to expansions. I guess this is important. So what we're going to move into now, so you now know the basics of moving around your file system and working with files, right? You also know how to use commands. So what we want to start to do is we want to start to write bash programs, right? And the first thing that you learn when you make a program, one of the first things that you learn is how to make a variable, right? Now the funny thing is variables are a bit funny in bash, and so that's what this expansions notebook starts to tell you about, right? So expansions, it turns out it's not just variables in bash, it's a bunch of things in bash. The individual words and the arguments that you specify on the command line, the bash manual calls these tokens, right? And so the space is used to separate tokens, right? So it's the word separator in bash. Space, tab, and the new line character are all considered word separators, right? Okay, so when you have a token in your shell, the shell performs what's called an expansion on the token, right? So all the word expansion means is it takes something and replaces the something with its expansion, right? So there's 7 kinds of expansions in bash, right? And you've seen some of them already, right? So you know what tilde means, right? So when I say tilde, you know that's the home directory, the current user's home directory. What actually happens when you type in some command that has the tilde in it, or when you use the tilde to indicate your home directory, the shell replaces the tilde with your home directory name, right? So that's called the tilde expansion, right? Take the tilde, replace it with its expansion. Its expansion is your home directory. So it's as if you had literally typed in, so here. So if I were to do ls tilde, right, you get the contents of my home directory, right? So what the shell actually does with ls tilde, right, is it takes the tilde, expands it to the absolute path name of your home directory. So the command that actually runs is that, right? Bash takes the contents of tilde, takes the value of tilde and inserts it into the text, or replaces it with the name of my home directory, right? And of course you get that. Right, if you type in tilde 2024F like that, right? Bash replaces the tilde, or the shell replaces the tilde, with the value of my home directory name. So it actually does that, right? So that's what an expansion does, right? Replaces the thing, right, whatever the expansion is, with the value of the expansion. You've also seen file name expansion, right? So when I showed you how to use the star and the question mark and the square brackets, right, to specify a wildcard pattern, what Bash actually does is it performs file name expansion, right? So it finds all of the files matching the wildcard pattern and replaces the wildcard pattern with all of those files. Oops, sorry. Come back here. All right. Okay. So for example, if I was to type in ls dir star, right? You know that it's going to list the contents of dir1, dir2, and dir3, right? Because dir star matches dir1, dir2, and dir3, right? What the shell actually does when you type in ls dir star, press enter, right? It replaces the dir star with this expansion. So what actually happens is dir1, dir2, dir3, right? So the command effectively runs as though you had typed in all of the matching file names manually, right? If you were to type, if you were to do cat star.txt like that, right? So this is a file name expansion, right? There's a wildcard here. So it's going to replace the star.txt with a.txt and a words.txt. So in other words, the command that actually runs is a.txt and a words.txt, like that, right? So that's what these expansions do. And it turns out there's 7 kinds of expansion. They happen in a particular order, so the order that they're shown here. And you have to remember that all of this stuff is, well, so you don't have to remember. You can get away with using the shell without actually knowing these expansions are happening. But you can't program effectively without knowing these expansions are happening, right? So you always have to remember, look, when I type in one of these things, there is an expansion happening. They occur in a certain order, right? Okay. Oh, who's that? Okay. It's fine. It's okay. All right. Okay. Right. So this notebook only shows you the expansions. It doesn't go into great detail into most of them, right? There are entire notebooks dedicated to some of them, right? In particular, parameter expansion, right? That thing there is basically how do you use a bash variable, right? So there's an entire notebook on how to do that. Okay, brace expansions. So we don't use these very much in this course. I do tell you about them because you need to know, well, so you don't need, they're occasionally useful, but honestly, they're not super useful. So let me show you what they mean by that. So a brace expansion is a mechanism for generating strings that follow a pattern, right? But the strings that it can generate are pretty limited, right? Okay, so basically what it lets you do is you can generate strings that have this pattern here, right? So pre is just a string that appears in front of every string that's generated, and post is a string that appears at the end of every generated string, right? So pre for preamble, post for postscript, right? They're both optional. It's called a brace expansion because, not surprisingly, there's something inside of braces, right? So the thing inside the braces is either a series of 2 or more comma separated strings, so like a comma b or x comma z or something like that, or a sequence, so something that defines a sequence, so 0 through 9, a through z, capital A through capital Z, or something like that. Right? Okay, so that expansion there, right? So basically what happens is if you have a comma separated list of strings, then the brace expansion will generate one of every comma separated string, right? So brace A comma B comma C produces the strings A space B space C, like that, right? So that's so you get that string there. Right. Now, if you have a preamble and a postscript, then the preamble shows up before every, the preamble shows up before every string, and the postscript shows up after every string, right? So here we're going to get and, right? There's a ampersand, so notice the escape character here because the ampersand is special. So if I want the literal ampersand, I need to say backslash, right? And also. So before underscore and underscore after, before underscore ampersand underscore after, before underscore also underscore after is the string that gets generated there. Right? So not terribly complicated, right? Take the preamble, stick it in front of the first string, slap the postscript after it. Repeat the process for everything inside of the braces. Right? So instead of a comma separated list of words, you can use that thing there, which is a sequence expression, right? Notice this is different than the way you wrote this using character classes with the wildcard expansion, right? So the syntax is different. You cannot use this syntax inside of the square brackets when you use a wildcard, right? This only works for brace expansion, right? So a sequence starts at x, goes up to and including y, in increments of that value there, right? So x and y are integers or single characters. Increment is the step size, right? 0 dot dot 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Increments of 1, right? Brace expansion is sort of, well, kind of, understands that you might want a decreasing sequence, right? So 9 dot dot 0 gives you 9, 8, 7, 6, 5 down to 0. Right? You can specify an increment, right? So 10 dot dot 20 dot dot 2 is 10, 12, 14, 16, 18, 20, right? Increments of 2. If you go in increments of 3, right? Notice you don't get the 20, right? You don't get 22 either, right? So it stops at or before the ending value. Right? Characters are just numbers in Bash. So a through a dot dot g, it knows that you want the letters A through G, right? A through Z in steps of 2, A, C, E, and so on and so on and so on, right? Okay, so the types of patterns that you can generate are fairly limited, right? It's sort of useful for generating things that look like dates, right? So here, I have 2 brace expansions, right? So here is one, is the years 2019 through 2022, right? Followed by a dash, followed by the months 1 through 12, right? 0, 1, 0, 2, 0, 3. Notice that it's smart enough to know that you want to prepend the 0 in front of everything, right? So this makes a whole whack of directories like that, right? It makes all the directories from 2019-01 up to 2022-12, right? So from there to there. Sort of useful if you're working with data that involves categorizing it into a bunch of dates. Right. Similarly, you can create a whack of files, right? Numbered 00 through 30. Right. So that makes sorry, it's hard to read. File 00.txt, file 01.txt, and so on up to file 30.txt. Right. And then if you look at the bash manual, there's a slightly more complicated example there. You can run that and see what that produces here. Right. This is not the most useful type of expansion, but it does exist. All right, so it's 20 after. I should stop there. We'll pick up this notebook at the beginning of the next lecture tomorrow.